Welcome back! Today we're diving into the fascinating world of radial gates, massive structures used to control water flow in dams, canals and spillways. Whether you're an engineering enthusiast or just curious about how these systems work, stick around. We've got a detailed sketch, a working mini model and real-life footage of a radial gate in action to break it all down for you. Let's get started. What is a radial gate? Before diving into the details, let's first understand what a radial gate is. Also known as a tainter gate, a radial gate is a curved, hinged structure used to regulate water flow in hydraulic systems like dams, spillways and canals. Its unique curved design allows it to efficiently handle large water pressures while being relatively easy to operate. Radial gates play a crucial role in flood control, irrigation and maintaining reservoir water levels. In this video, we'll explore the key components of a radial gate using this detailed sketch, and I'll demonstrate how it works with a mini model I built. Let's start by breaking down its parts. Key components of a radial gate. Let's take a closer look at the components of a radial gate as illustrated in this solid edge sketch. 1. Gate leaf and skin plate. The gate leaf is the main curved structure that blocks or allows water flow. The skin plate is the outer surface of the gate leaf, designed to withstand water pressure. Together, they form the barrier that controls water movement. The curved shape helps distribute water load evenly, making the gate stronger and more efficient. Trunnion. The trunnion is the pivot point of the gate, similar to a door hinge, allowing the gate to rotate open or closed.
So here we are standing on the radial gate. This is the trunnion. This piece right here is the trunnion. This is trunnion.
Watch as our mini model smoothly rotates around the trunnion while opening, just like a real radial gate in action. 3. Upper arm and lower arm. These structural supports connect the gate leaf to the trunnion. The upper and lower arms ensure the gate moves as a single unit when it rotates, handling immense forces acting on the gate. Watch as we take a walk along the upper arm of this massive 440-ton radial gate, experiencing its sheer scale up close. 4. Hydraulic cylinder and cylinder hinge. The hydraulic cylinder is the powerhouse that moves the gate. Connected to the gate leaf via the cylinder hinge, it pushes or pulls the gate open or closed. Hydraulic systems are used because they generate the massive force needed to move such heavy structures with precision. Each hydraulic cylinder of this gate has the power to lift an incredible 600 tons, showcasing its immense strength and engineering precision. 5. Anchor bolts. Anchor bolts secure the trunnion to the concrete structure, ensuring the gate remains stable while rotating. Watch the massive anchor bolts embedded in concrete, securing the 440-ton radial gate in place. Just for reference, each trunnion alone weighs nearly 50 tons. 6. Sill beam. The sill beam is the base where the gate rests when closed. It provides a tight seal, preventing water from leaking through. 7. Gate guides and lintel beam. Gate guides are vertical tracks that keep the gate aligned as it moves up and down. The lintel beam, positioned above the gate, ensures proper top sealing for smooth operation. 8. Locking device. The locking device secures the gate in position when it is fully closed, preventing unwanted movement due to water pressure or vibrations. Each of these components works together, making the radial gate a robust and efficient system for water control. Now, let's see how they function in action, how a radial gate works. Now that we know the parts, let's see how a radial gate actually operates. When the gate is closed, the gate leaf rests against the sill beam, blocking water flow. The hydraulic cylinder is fully extended, holding the gate in place. To open the gate, the hydraulic cylinder contracts, pulling back and exerting force on the gate leaf. This causes the entire gate to rotate around the trunnion. The gate leaf lifts upward, allowing water to flow underneath. The The curved design of the gate ensures even water pressure distribution, reducing stress on its components. The gate guides and lintel beam keep the gate aligned, preventing any wobbling or misalignment. To close the gate, the hydraulic cylinder extends, pushing the gate back down until it seals tightly against the sill beam. This mechanism allows radial gates to handle massive water volumes with precision, making them an essential part of water management systems worldwide. Let's bring this to life with my mini model. I've built a scaled-down version of a radial gate, complete with a working mechanical mechanism. Watch as I open the gate. You can see the upper and lower arms rotating around the trunnion, just like in the sketch. In the real world, radial gates are much larger, sometimes spanning over 50 feet across. Here's a real radial gate in action, opening to release water during a controlled operation. These gates are often used in dams to manage floodwaters, ensuring that reservoirs don't overflow. They are also used in irrigation systems to regulate water distribution for farming. The engineering behind radial gates is a perfect blend of strength, precision, and efficiency. Let's wrap up with a final look at the mini model, the gate sketch, a real-life radial gate in action. If you enjoyed this deep dive into radial gates, don't forget to like this video, subscribe for more engineering content, hit the notification bell so you never miss an update. Let me know in the comments if you'd like to see more videos like this, or if you have any questions about radial gates. Thanks for watching, and I'll see you in the next one.
पानी का साफ नहीं होता है छोड़ो आज